Hi everyone. All drive systems always consist of two basic parts. First of all, there is a source, which is often a motor, and the source delivers force, speed, and therefore mechanical power. On the other hand, there is a load, and the load requires force and speed, and therefore consumes mechanical power. So first of all, let's look to the source, the motor. And the motor delivers force and speed. And the multiplication of force and speed is the mechanical power P. So the motor power P. And in this plot, I've drawn a motor characteristic. And on the horizontal axis, we have the motor speed V in meter per second. And on the vertical axis, we have the motor force in Newton. And it's a typical motor characteristic. And it's a typical motor characteristic because it starts off with a high force over here, the intersection point with the vertical axis, so at speed 0. And when the speed increases, then we see that the motor force decreases until we are here at the maximum motor speed V0 at a motor force which is equal to 0, so the intersection point with the horizontal axis. This is motor characteristic M1 and this is motor characteristic M2, which could be the characteristic of a different motor. Could also be the characteristic of the same motor, for instance, when we lower the motor voltage. Note that this is applicable for a translational system because we have a motor speed V and a motor force F. And when we have a rotational system, V is replaced by an angular velocity, omega, and radians per second, and the force is replaced by a torque T in the unit Newton meter. So that is the source. Now let's look to the load. And the load requires a force and requires a speed and therefore consumes a mechanical power which is equal to F times V. And also for the load, we can draw a characteristic over here, and we set the on the horizontal axis the speed again, V in meter per second, and on the vertical axis we have the motor or the load force F in newtons. And this is a typical load characteristic because it starts off at a certain point here on the vertical axis where the speed is 0, which is often caused by a load force or a friction force. And when the speed increases, we see that the load force, so the force which is required by the load, increases, often due to viscous friction. So that is a typical load characteristic over here, L1 or the blue one, L2. Now let's see what happens if we combine the source, the motor, with the load, the mechanism, for instance. Then we get the two characteristics in one graph over here. The red one, which was the motor characteristic, source characteristic, and the blue one, which is the load or a load characteristic or the characteristic of my mechanism. And the intersection point of the two characteristics is point B over here. And in that point, we see that the motor force is equal to the load force over here. So the motor force is the load force, which is this force. And we have on the horizontal axis the point where the speed of the motor, V motor, equals the load speed. And that is equal to the speed VB. So the intersection point of the load characteristic and the motor characteristics define the speed at which the motor and the load operates and the required motor and load force. And that complies to Newton's first law, which states that an object at rest remains at rest, or if in motion, remains in motion at a constant speed and in a straight line, unless acted on by a net external force. So now let's see what happens if an external force is applied to that system. So this was my operating point over here, B1. And now let's see what happens, for instance, when an electric car drives onto a bridge. So what happens is at that time, the motor load is, or the load torque, I should say, or the load force is increased suddenly. So we have a new load characteristic over here. So the load characteristic L1 changes into a new load characteristic L2. And because the speed can't change immediately, we see that we have a new load force over here at this speed V1, and that load force F3 is higher than delivered motor speed, or the motor force F1 over here. And due to Newton's second law, which says that the motor force minus the load force equals the acceleration force, m, the mass of my mechanism, the mass of my load, times the acceleration a, we see that due to the increase of the load, F1 is lower than F3. So we have a negative acceleration force. In other words, my system starts to decelerate. So again, we were operating in this point. My load is suddenly increased. So we have the load characteristic L2 over here, and the load force F3 is higher than the motor force F1 at that point. So my system starts to decelerate until we have a new intersection point of the motor characteristic with a new load characteristic, so intersection point B2, in which the motor and load speed have dropped to a lower value, V2, and the motor and load force are higher than the original motor and load force in the original operating point B1. All right, that's all for now. See you in another video. Bye bye.